Did you know since ancient times, distillation is used to distillate on fermented solutions to produce distilled beverages with high alcohol content. Therefore, the purpose of distillation is to separate a mixture into purer or more concentrated different components of the original mixture. Here is the distillation overview.
The principle for operation of a distiller is simple. Example, water is heated to boiling in an enclosed container. As the water evaporates, inorganic chemicals, large non-volatile organic chemicals, and microorganisms are left behind or killed off in the boiling chamber. The steam then enters condensing chamber where the steam is cooled by air or water and condenses back to a liquid. The distilled water then goes into a storage container.
There are many types of distillation. The first one is simple distillation. Next is vacuum distillation. The third one is fractional distillation. Last but not least, steam distillation. Simple distillation. Simple distillation is a process to separate two liquids with boiling points or a liquid from a non-volatile compound with higher viscosity. In simple distillation process, mixture is heated to a boiling point in which would result in vapor condensed immediately into liquid form. It is widely used in alcoholic beverages industry to produce high concentration of alcohol. Simple distillation is used in the production of alcoholic beverages such as vodka and whiskey. It relies on the difference in boiling point between ethanol alcohol and the mixture or mash used for fermentation and the initial synthesis of alcohol. Next is vacuum distillation. Vacuum distillation is a process of lowering the pressure in the column above the solvent to less than the vapor pressure of the mixture, creating a vacuum, and causing the elements with lower vapor pressures to evaporate off. It lowers the pressure below atmospheric, results in lower temperature requirements to achieve evaporation for elements of the distillate, in which it will lower the overall heating requirements for the system. Vacuum distillation is commonly used in petroleum refining industry. In petroleum refining industry, vacuum distillation helps to produce petroleum products out of the heavier oils left over from atmospheric distillation. It separates the lighter hydrocarbons from the heavier oils based on boiling point, which up to 600 degrees Celsius, and produces several types heavy distillates, such as jet fuel, kerosene or diesel, and in the next stage it produces light distillates like gasoline and naphtha.
Fractional distillation is a type of distillation which involves the separation of miscible liquids. The process involves repeated distillations and condensations, and the mixture is usually separated into component parts. The separation happens when the mixture is heated at a certain temperature where fractions of the mixture start to vaporize. The basic principle of this type of distillation is that different liquids boil and evaporate at different temperatures. So when the mixture is heated, the substance with lower boiling point starts to boil first and convert into vapors. A common example of fractional distillation in industries is the separation of various components of crude oil. Crude oil normally contains substances such as paraffin wax, gasoline, diesel, naphtha, lubricating oil and kerosene. The distillation process helps in separating these components effectively.
Steam distillation is analogous to simple distillation, the main difference being that steam is used in the distilling flask along with the material to be distilled. The steam, which acts as heat source, carries the vapor of the volatiles to a condenser, where both are cooled and returned to the liquid or solid state, while the non-volatile residues remain behind in the boiling container. Steam distillation are widely used in the manufacturing of essential oils, for instance perfumes. This method uses a plant material that consists of essential oils. Mainly orange oil is extracted on a large scale in industries using this method.
Meaning of distillation in lab. Distillation is a purification method for liquids and can separate components of a mixture if they have significantly different boiling points. In a distillation, a liquid is boiled in the distilling flask, then the vapor travel to another section of the apparatus where they come into contact with a cool surface. Meaning of distillation in industry. Separate mixture of liquid by exploiting differences in boiling point of different components. Component of lab distillation. First component is stable stand or rack is used to prevent distillation apparatus from falling over. Second is the condenser must generally be connected to a source of running water to provide cooling for the vapor, and this is the distillation flask should preferably be a round-bottomed one rather than a flat-bottomed one for smoothness of boiling. Lastly is thermometer is to measure the temperature of the vapor condensed. Component of industry distillation. 1. A vertical shell where the separation of liquid components is carried out. 2. Column internals such as trays, plates and/or packings which are used to enhance component separations. 3. A reboiler to provide the necessary vaporization for the distillation process. 4. A condenser to cool and condense the vapor leaving the top of the column. 5. A reflux drum to hold the condensed vapor from the top of the column so that liquid reflux can be recycled back to the column.
The process of distillation is the process of evaporating or boiling a liquid and condensing its vapor. Also purification or separation of mixture by using different evaporation rates or boiling points of their components. The process of distillation in lab. First of all, salty water is heated, then the water vapor cools in the condenser and drips into a beaker. Finally, the water has condensed and is now in the beaker, the salt stays behind.
This is the process distillation in industry.
1. The refining process begins with the fractional distillation of heated crude oil. 2. The crude oil components gas, gasoline, naphtha, kerosene, light and heavy gas oils, and residuum are separated into lighter and heavier hydrocarbons. 3. Light hydrocarbons are drawn off the distilling column at lower temperatures than are heavy hydrocarbons. 4. The components are then treated in many different ways, depending on the desired final products, shown at the bottom. 5. The conversion processes are shown as blue boxes.
Hi, I'm gonna share with you the advantages of distillation. It has high purity products, economies of scale, well-established technology and competitive supply of equipment, use of low temperature and low-cost energy, well suited for energy integration into the surrounding process.